All right. Picking up where we left off here. Oh, come on. You should take out your calculator so you can follow along as we're kind of running through these examples. Okay. Here we go. This is where we left off. A company that specializes in job placement services is interested in finding out if salaries of recent Master of Arts graduates in marketing are less than the salaries of finance graduates. Random samples of 25 each from both subjects were collected, and the data is as follows. So again, we're going to be using what statistical test to test for if these are different or not? It's called the t-test. And since we're comparing two different samples, this is the two-sample t-test. In IB Mathematics, you'll always be doing the pooled version of the two-sample t-test. There's an unpooled version also. You're not responsible for knowing how to do that or how to set that up or anything else. They'll always be pooled. And remember, the pooled has to do with like the variance of the two populations you're sampling here. If we're pooled, we're assuming they're equal variance. Anyways, so the marketing average salary from our sample is $60,423 with a standard deviation of 16,193. And the finance is $65,624 with a standard deviation of 18,985. We're going to test at a 5% significance level. So what do we start by doing? Where do we go to find this test on our calculator? Help me remember the buttons. Stat. Test. Two-sample t-test. What should have we done before we press this button, though? This is my fault for saying asking you the buttons. We write our hypotheses, right? So here, if we want to know if they're the same, we're testing this. The null hypothesis is that the means are equal. And our alternative is that the marketing degrees earn less than the finance degrees. Then we go in and we set this up. So that's what your setup should look like. So our mean one is the marketing. Our sample one is the marketing, and the sample two is the finance. Remember, in the story situation, said there are 25 samples of each. And our alternative is mu1 less than mu2. And we're always doing pooled in the IB course. So our calculation is here. And our graph, if we wanted to graph it, was here. From the output, what value are we concerned with primarily? P. That tells us what's going on. What should we be comparing P to in this case? Yeah, this level of significance, which was 5%, or rather 0.05. Notice our P is definitely bigger than 0.05, so we failed to reject the null hypothesis, which indicates that the two salaries are really kind of the same, even though the means from our samples were kind of different. And notice here, since we're looking at the stuff less than This was called the lower tail. Remember, that's how we name these things. Okay. So let's talk more about this value for t now, the so-called critical number. So in our last example, we got this graph, right? And the t was this negative 104. So when we look at this picture, the p-value is actually the amount or the area under the curve that we've shaded. So using our level of significance, we can take our graph and figure out how much of the graph needs to be shaded ahead of time. So figure out like what is 5% of the graph shaded on the left side look like. That's what we call the critical value, not the critical number, but the critical value is the x value on the x-axis that corresponds to like everything under that is shaded, or is 5% of the graph shaded. Everybody's okay? Then we can take that critical value and compare that to our critical number, much in the same way we compare p and alpha. So doing that, do you need a t-value? Nope. So you will be asked and expected to interpret results that could be done either with a t-value or a p-value. Since level of significance must be stated at the start of the question, generally it's easier to compare the p-value with the alpha than trying to figure out the associated critical value in order to use your t-value. But if we tell you the critical value, then all you're doing is comparing with the t, right? So let's do another example. It says a national magazine in the U.S. claims that the average college student watches less television than the general public. The magazine collected data from the following samples: non-college with a mean of 29.4 hours of television and a standard deviation of 2.1 hours, and the sample there was 1,200 people. And our college mean was 28.9 hours, a standard deviation of 1.8 hours, and a sample of 900 people. And we want to test this with a 1% level of significance. So let's start by writing our hypotheses. What would we say?
Non-college watches the same as college.
Okay, so mu1 equal mu2. And our alternative would be?
mu2 is less than mu1.
Right, that the college TV watching is less than the general public. Mu2 is less than mu1. Or you could write it in the order this way. Mu1 greater than mu2 says the same thing, right? Okay, let's get this data into our calculator and see what it says. Look at that crazy p-value. That is itty bitty teeny weeny. Because you can't forget to read the whole number to see the e at the end. Although, if you remember, p is a probability, So if it starts 5 point something, something is very wrong if it's actually the number 5 point something and doesn't have a times 10 to the negative at the end. Because you can't have a probability bigger than 1, right? So if we look at this, the p-value is less than alpha, so that rejects the null, indicating that college students do indeed watch less TV than the general public. If you looked at this example in the textbook, they did this the other way, as they called the college mu1 and the non-college mu2. So they ended up doing like an upper tail rather than, or a lower tail rather than an upper tail. But we know that the answer is going to come out the same way. We did this example previously where we switched them around and saw that we get the same result. Okay, let's do another. Atkins diet, eat right, not less. This is what this method of low carbohydrate, low sugar diet advertises. Scientists at a university selected a random sample of 32 subjects from their local population of obese adults. They randomly assigned 17 to the Atkins diet and 15 to a conventional diet. Does this experiment show at the 5% significance level that the Atkins diet leads to a loss in mass of 5 more kilograms a year than a conventional diet? So in the table, gives the mass of loss positive or gain negative for each subject. So how do we start? Before that, we write our hypotheses. But notice here, this experiment isn't asking for just a straightforward, like, Atkins leads to more loss than the conventional, right? What did it say specifically? It needs a specific threshold of more. So we have to make sure we account for that when we write our hypothesis. So I would say Atkins diet loses less than 5 kilograms more than the conventional. Everybody's okay with how I wrote that? And my null then would be the Atkins diet loses more, or my alternative would be loses more than 5 kilograms more than the conventional. So far, so good. We have our hypotheses. Now, in the past, we've been given like process statistics to use rather than just raw data. Here we're given raw data. So what are we going to have to do? We'll process it on our own, right? What do we need to do our t-test?
Mean and standard deviation.
Mean and standard deviation for each sample set, right? So let's use the calculator to do that. So how would I do that in my calculator?
Go to stats. And then
Yep, and I'd put the Atkins diet in L1 and the conventional diet in L2. So next, we have to count for that extra 5 kilograms. So we're going to adjust one of our lists. Which list do you suppose is the one that we adjust?
List 2.
Because it's the conventional, and the way we wrote our hypotheses was the conventional plus 5, right? So what I'm going to do is I'm going to move my cursor so that it's on the L3 on the title there and press enter. And then type in L2 plus 5. See how down here? So you move your cursor up onto the title of L3 and press enter and then type in L2 plus 5 and it'll fill the whole list for you with everything from L2 with 5 added to it. And keep in mind, you could have, if you switch like the order of some of the things, you could have subtracted 5 from L1 and this still could have worked out. But since we already wrote our hypotheses the way we wrote it, we had written it, wrote as a word, right? Roten, though. No, not so much. Okay. So now we're all set, right? So we could find the means and standard deviations with the calculator, that's fine. But if you notice when we do the t-test, one of the options is input data. So let's do that, and the calculator will actually do all the heavy lifting for us. So it looks like this initially, but I need to make sure I've updated things because I want to be using L1 and L3, and I need to be looking at mu1 greater than mu2 because now I've done, right? UC plus 5 is L3. Everybody agree with that? Okay. And now we're ready to rock and roll. So let's hit calculate and draw. So here's our p-value. We're comparing this to 5%. What do you notice? P is much bigger than alpha, right? So that we failed to reject the null, which means that the Atkins diet fails to demonstrate that you get more than a 5 kilogram weight loss than the conventional diet. Okay. That's the end of section 13.1. Your problem set for Sunday, you know what? Let's not worry about it for Sunday. We'll have it due next Sunday because we won't have a chance to ask any questions before would ask you to do it. So that 1 through 4 on page 446 will end up being for next Sunday. Yeah, it's only 4 problems.
I think last class you said
40? Oh, I must have just garbled that one.
I was like, oh.
I don't think you're ever going to get 40 problems in a homework.
Yeah, I know.
That seems excessive, doesn't it? Yeah, that's scary. Okay, everybody's good? I'll adjust that on my Notre Dame, but I'm saying it now aloud to everybody, so hopefully you hear. What I do need from you today is to pick a project if you haven't picked a project, and to get a survey done. Talk to me about your survey because I'm going to have feedback for you on it because you're probably not going to be good enough the first time you show it to me, which is normal. I'm only going to be picky about it so that I can help you get the data you need in order to get a decent outcome on this. Although if you have a crappy outcome, that's okay. You just talk about why it's bad and it's fine. It's not part of the grade. Luke.
So do you want us to show you our surveys Monday and then?
No, today, before we leave. I want it written today. You have an hour to write like a 2 or 3 question survey. That's it. That's all it needs to be. It's good. How should you write it? I know. Use a Google form. You do it a Google form, unless you're like Isaac, who is doing something different for his data source, in which case you should present to me how you're going to sample, like your method for sampling, and then you can start sampling. You don't have to wait on anybody because your data is publicly available, so it's just a matter of you doing it. So you should work on doing that while everyone is writing their surveys, but we'll still have the same conference about like making sure everything looks kosher. Okay? Everybody good? Okay. If you need to talk to me about any or all of it, let me know. When you think you have your survey written up and you want to talk about it, bring on up and we'll talk.